Okay, we're live now. Do you guys have the quiz open?
Yes,
Okay.
I do have it.
Okay, so first two are always persons. Okay. So question number 3. Okay. We'll give you a sec to Daniel. Hey, say hi to her. Okay. Use the normal probability applet to find the combined area under the standard normal curve that is to the right of z equal 1.358 and to the left of z equal minus 1.358. Round your answer to 3 decimal places. And it's okay. We need the applet. So the area on the left and the area on the right of 1.358.
I got 0.175.
Mm-hmm. Yeah, me too.
Okay. Okay. Do you want me to read this one?
Thank you. Yes.
Okay. Which of the following will have a smaller standard deviation if 9 observations are randomly drawn from a population? The distribution of the individual observations, X. The distribution of a sample means X bar, or it cannot be determined.
That's interesting. Smaller standard deviation.
I would say like the distribution of the sample means, because the standard deviation should be smaller, but I don't know.
No, I'm not sure about that, because if the sample is bigger, the standard deviation should get smaller. I don't know. This might be totally wrong, but
I don't think I know this one myself.
Well, when we were, is it me?
well,
Do you hear that noise? Yeah, I think it's
a little cracking.
Yeah, I think it might be my microphone. Okay, I will talk not too loud then. I think when we did all those simulations, with that other website, do you remember when we had those 3 different graphs?
Oh yeah.
yeah.
I think then when we were using that, the standard deviation was lower, because like when we do the z-score for the distribution of sample means, when we divide by the standard deviation, we use the population standard deviation divided by the square root of n.
The number of the samples.
Exactly. So that means that that's smaller because you're dividing it by a square root.
Yeah. So the bigger this, the number under the square root, the
yeah, exactly. If
that makes sense. It makes sense.
So we can try and see what happens.
Yeah.
Okay. The distribution of the sample means. So the second one for now.
Yeah. Since I'm making this call, I'm going to submit later and see what happens.
Which of the following results implies that the spread in X over bar decreases as the sample size increases?
Okay, I have to read it again.
Yeah, me too. No, it's just complicated. Okay, which of the following results implies that the spread in X increases size increase? Well, this is answering the previous question, isn't it?
No, not really.
Well, that the sample size. Okay, I might be confused. Okay. Well, not the second one.
No, not the second one.
Not the first one either.
Yeah, central limit theorem.
Oh, that the spread, but the spread from what? You know, because it's like,
Yeah, I'm not sure what that means.
because if we're talking about the distance between X bar and the population mean, then that's the law of large numbers. That it states that the larger the sample, the closer the
To
mean
the
of that sample will be to the mean of the population.
Right. But if is, I'm wondering if that refers to the sigma divided by the square root of n. I'm wondering if that is still referring to that. Does it make sense?
Mm-hmm.
Because in that case, it's different.
So we all agree it's either the central limit theorem or the law of large numbers.
I think so, yeah.
Yeah, I think so too.
Okay, I'm actually looking at the notes.
This is what it says for law of large numbers. It says, as the number of repetitions increases in an experiment, the proportion of an outcome observed gets closer to the probability of the outcome.
Mm-hmm.
I don't know if that really matches with this, but I know like as the sample size increases, for example, or the number of repetitions, the proportion of the outcome observed gets closer to the probability of the outcome. And then for the central limit theorem, it says, if the sample size is large, the random variable x bar will be approximately normally distributed.
Mm-hmm. Well, I'm looking at the textbook, and for the law of large numbers, it says that it states that the sample mean x bar will be close to, what's that, like bit? What heck of a letter is that? The one that signifies the population mean.
I don't know.
Yeah, well,
I think it's
that U with the long leg, you know.
Oh, then I think it's mu.
Mu? I don't know.
Yeah, mu.
I have no idea. I'm pretty
Okay.
bad with.
Let's call it mu.
Mule. Okay.
So the law said that if the sample size is large, then the sample mean would simply be close to the population mean.
Because like the law of large numbers, when it talks, sorry, the central limit theorem, when it talks about, you know, x period. So like x period stands for the mean value of our observations. Right?
Sorry, I wasn't paying attention.
X bar is the value of our observation.
The simple mean. Okay. It's the simple mean. X bar is the simple mean. So if we have our simple mean, like if the central limit theorem says that simple mean is the same as the parent population mean.
Okay.
You know, because it says that it's the same.
So you're thinking central limit theorem then?
I think it's the law of large numbers.
Okay. That's what I clicked. That's what I clicked originally. That's what I clicked originally.
I don't know, because
The
We'll
simple
submit it and
mean.
we'll see who's right.
what you were saying, Gabriel, is that the value, each value within the observation, it's going to have a lower spread because the deviation, the standard deviation, it's going to be lower. But it's not talking about the mean.
Mhm.
It's talking about each and every observation. It's going to be less further away from the mean. But I don't know. I think here it's talking about the mean of that observation, because the X bar should be the mean.
But so the question is asking which of the following result implies that the spread between the mean of the sample and or not? No.
It doesn't say, but since it's talking about one mean, I think it's going to compare it to the other one. Otherwise, what the heck is it going further away or less further away from? You know, it's like, what are we measuring it against?
Okay, because in that case, I'm reading that the law of large numbers states that if the sample size is large, then the sample mean will typically be close to the population mean. This happens because it's standard. Yeah, so
that's what I'm thinking about.
So at that point, I will say the law of large number.
Well, we have 2 attempts, you know, so let's just try. You know, it's like, and we will remember it, you know, from the next time. Yeah.
Okay, the next one says scores. Okay, oh, sorry, I gotta click. Okay. Scores on the quantitative portion of the GRE are approximately normally distributed with mean equal to 150.8 and standard deviation equal to 8.8. Diane earned a score of 160 on the quantitative portion of the GRE. What is the Z-score corresponding to Diane's score? Round to 3 decimal places. Okay. So I think we have to do 160 minus, what is that, 150.8?
Yep.
And divide that 8.8. And I'm getting 1.045.
Yeah, and so in this case, it would just be divided by 8.8 because the number of observations is just 1.
Yeah.
Is that
Yeah, because it's like we're just looking at that case. We're not drawing a sample from a population.
Okay. So it's 1.045 then, right?
1.045, yeah.
Yeah, that's what I got. Okay, cool.
Isn't 046?
No.
0, okay, sorry, there are too many numbers.
Yeah.
What
is the probability that randomly selects? Oh, okay, and so then you just put that into the applet, I think. That's the Z-score.
The randomly selected student will score above 160. Yeah. 1.045.
So it's 0.1480.
Yeah, we have to put 3 decimals, so yeah. 0.148. Chisega,
That one's
are you there, Gabriel? 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 Oh, Gabriel. I don't know. I think he is exploring the vastity of Kolob, you know? Gabriel.
There we go. I'm back.
Because
It was really fun. Last time after I posted the video, I actually looked at the video and I saw the part where I was not in there. It was quite a fun. Okay, where are you guys at? Question number 7.
Yeah.
Okay.
So remember how we got the z-score?
Yeah, we just put the z-score.
Into the applet, and then you just
Okay.
to the right of it.
Yeah, and is it 0.148?
Yeah.
Good. Okay, question number 8. A random sample of 5 students was selected to take the GRE. Their scores are blah, blah, blah. What is the z-score corresponding to the sample mean of these students' scores? So this one is different. Good.
I'm sorry, guys. Just one thing. For number 7, because I was just like distracted for a moment. Did you put 0.148?
Yes.
Okay, cool. I'm good.
Okay, so
Okay. The z-score for this sample mean. Okay. So that's 60 plus 175.
oh, dang it.
Okay. Can you hear them crying?
Yep.
All right, I'll turn off my microphone for a moment.
Okay. It's like not very loud at all.
I came up with 2.338.
Yeah, I did a few. I did 2 of them, and I got 3.42 when I rounded my the square root of 5, and then I got 2.57. So I got 3.42 and then 2.57.
Okay, I didn't get any of those 2.
That's okay. I'm gonna use Excel. Maybe it'll come out different. Did you use like
No, I used my calculator.
use your calculator? Okay.
Yeah.
I'll plug it into Excel. Use
What did you get, Daniel?
2.338.
That's what I got too.
2.338.
Yeah.
Let me see real quick. Plus 175 plus 163. Oh, what am I doing?
So 160 is the
mean.
Is the mean, right?
Yeah.
Okay.
So we do 160 minus 150.8,
Which gives 9.2.
and then you divide that by 8.8 divided by the square root of 5.
So divided by the square root of 5.
Yeah.
9.2 by that. 3.37?
Yeah, 338.
338.
Oh,
Yeah.
yeah. You're right. 2.33. Yeah, 2.33.
Okay. So 2.338. Save.
Okay. Question 9. What is the probability that 5 randomly selected students will have a mean score that is greater than the mean achieved by the students in the previous problem? Okay. So what's the probability that 5 random students will have a mean score that is greater than 160?
Not many.
So we need that z-score, right?
Mm-hmm.
And put it into the whatever thing. Put that through. Where's greater? Is it like 0.097?
Yeah, so I got 0.010 just because I rounded to the 9.
Yeah,
But
sure.
I don't know.
Yeah, we can get around that. So 0.01.
Yeah.
No, guys, it says that you have to round to 4 decimal places.
Oh, okay.
Oh, okay. So 0.097.
Okay, so it's correct then. Yeah, good catch.
Daniel, do you want to read the next one?
It might be best if you do that. So I can keep my microphone off, or you will keep on hearing girls crying, you know?
Okie dokie. Suppose the mean GPA of BYU Idaho students is 3.5 and the standard deviation is 0.7. It is well known that this distribution is less skewed. A random sample of 81 students will be drawn. What is the shape of the sampling distribution of the random variable, which represent the sample mean of the 81 students who were selected? Approximately normal, let's say. Am I talking to myself?
No, I'm right here. Sorry, I'm
Okay.
still reading.
No, just
I'm writing. I'm writing. If you check, you know, I will write. So just keep an eye on.
oh, come on, don't just talk. They don't cry anymore. Don't worry.
What is the shape of the sampling distribution of the random variable x bar, which represents the Ooh, how do you? I'm not remembering how to do this one. I guess.
I think it's just because the the distribution of the GPAs as we read above is less skewed, but because the students the sample is 81, so it's greater than 30.
Oh,
It should be
Okay,
normal anyway.
Yeah. Okay.
So approximately normal. Daniel, do you agree?
Okay. What is the mean
Okay.
of the distribution of the sample means? Sampling distribution for all possible samples of size 81 that could be drawn from the parent population. So it's like the mean of the mean, right? Is that what it's saying?
What is it? Yeah.
Which is, what is it? It says sample of oh, it's 3.5, right?
I would say, yeah, it should be the same, 3.5. I was reading again just to make sure I was understanding what I mean. Yeah,
Okay.
should be the same. Yeah. Okay.
There.
Good.
12. What is the standard deviation of the distribution of the sample means for all possible sample size of 81 that could be drawn from the parent population?
The standard deviation. Oh. The standard deviation.
0.078.
Is. Okay. Sorry, I'm just still counting. 81 students, 0 points. 0.08, like 0.08. That's what I got.
Okay, standard deviation divided by square root.
Gosh, Daniel, I can't see what you're writing. Come on, just use the mic. Population standard deviation.
Population standard deviation.
Suare root of 81. Of 81 square? Oh, so, okay, got it. Gosh. So, if I did it right on my calculator, I got 0.08. Oh, 3 decimal places. Okay, 0.078.
What is the probability that the mean GPA for 81 randomly selected BYU Idaho students will be less than 3.5?
Okay. Let's
So I think we're supposed to use Applet for this one, right? Like plug in the z-score, I'm guessing.
Yeah.
I don't remember.
Trying to remember how to get that z-score.
Yeah. Me too.
Okay, so
Could be 3.3 minus 3.9.
I think we need to find the z-score of 81. You still typing? Experience. Okay. got the 0052.
So how did you get that, Daniel?
Okay, let me just double check one thing.
So what I did, I took the 3.3.
Yeah.
That it's the sample mean, and I I took away 3.5, that is the population mean.
You get a negative, don't you?
Yes, negative 0.2, and then I divided that by 0.078, that it's the standard deviation that we just calculated before.
I got a negative number. I got negative 2.56.
Yes, negative 2.564. If you
Yeah.
put that in the applet
Okay.
and you just look at the area far left, you will come up with 0.0052. But it says that we have to put only 3 decimal places in the answer.
So 0.005.
Mm-hmm.
Yeah, I was just not understanding where the 0078 came from, and yeah, we already have that. Okay. Question. Okay.
Just go click to the right of it, right?
What?
The applet.
It's the far left, because we're looking at, the question is asking us, what is the probability?
No, are you talking about the 14?
14.
Oh, sorry. I didn't hear it.
Yeah, 14.
Yeah, the far right, which is the same.
Well, it's everything except the one before. So it's also the big part in the middle.
Yeah, so 0.994 is what I got.
Mm-hmm.
Okay. Or 0.995, right? Because
Yeah, 995.
Wait, are we supposed to get the center one and the right?
Yes.
yeah.
The right one? Or just the right one? Because it's greater.
No, because it's greater. So you take
Oh.
everything.
Yeah, on the right, the -2, not the 2.56. Yeah, looking at it.
So 0.995.
Okay, 15. Daniel, you're on this. Before I'm going to talk.
The United States Coast Guard assumes the mean weight of passengers in commercial boats is 185 pounds. The previous value was lower, but was raised after a tragic boating accident. The standard deviation of passenger weights is 26.7 pounds. The weights of a random sample of 48 commercial boat passengers were recorded. The sample mean was determined to be 177.6 pounds. Find the probability that a random sample of passengers will have a weight that is as extreme or more extreme, either above or below the mean, than was observed in this sample. As extreme or more extreme means that we're not only interested in values that are lower than the ones we observed, but also values that are as far away from the mean as ours in the positive direction.
Mm-hmm. Yeah, interesting that sentence. Okay, so 48, so it's a normal distributed thing.
So we have to find the z-score first.
So 177.6 minus 185. And it's minus 7.4. Now we divide this by the standard deviation. It's 26.7. Divided by the square root of 48. correct?
Mm-hmm.
Okay, so it's minus 1.92. Correct.
Mm-hmm.
Now we need to find the p where what's that called?
I don't think
The
so.
p.
Yeah, well, like it just says here that we need to find the probability that that sample is as extreme, either below or also above, you know, that standard deviation, like that z-score. So we have to put it in the applet, I think.
Uh-huh.
I
And
think.
get both the far right and the far left.
Mm-hmm. I think so, yeah. And that
Yeah, it's
would
not
be-
asking to for the like to confirm or reject the null hypothesis.
Exactly. There's nothing about that.
So
So
0,
let's see.
0. So 0.0549.
Yeah, if we
Yeah.
round to 3 decimal places, it's 0.055. Zay, do you agree?
So
Does it make
I got
sense?
the z-score. The z-score that I got is 1.922. Is that correct?
I got 1.920.
Yeah, me too.
Okay, so 1.920.
Yeah.
And then you put that in the probability applet.
Yes.
And then you
what-
select the far right area and the far left, both of
Okay.
them.
Okay, so 0.0549.
5. Yeah. We round to 3 decimal places.
0.55.
I think I skipped something. Question number 6. What did I say? Because we're going for
0.05.
I'm submitting it.
okay. That is all your fault.
It's all good.
Good.
So
I'm not sure. I'm not sure I did the same as you, but okay, I will submit. Just kidding. Do we have to stop the recording after we submit or before? I don't know.
Yeah, we can stop whenever.
Yeah, I can stop it now.
Or we can just make it as longer as possible.
Just stop it, man.
Okay, okie dokie.